So do me a favor, write all that down. I would pause the video really quickly, okay? And let me pretty much say, if it's greater than or less than, it's dashed. If it's greater than or equal to, less than or equal to, it's solid. If it's greater than or equal to, it's up. If it's less than or equal to, it's down. Let me point out here, this line on the bottom is what makes it solid. Now, I threw this in here because I feel like we kind of struggle on what we're supposed to do when. So let's actually go over it, all right? I'm going to do number 1. And this should hopefully be review. If it's not, that's why we're going over it, I guess. All right, so I'm going to graph this. Down 7. Now I either go up and right, or I go down and right. It's negative, so I'm going to go down 3, right 2. Now, once I do that, sorry, let me zoom out a little bit. I have to decide, is it solid or dashed? Since it's greater than, it's dashed. And then I have to decide, am I shading up or am I shading down? Since it says greater than, I shade up. Okay, let's do the next one. Up 2, up 3, 1, 2, 3, 1, 2, 3, 4. Line on the bottom means solid. Am I shading up or shading down? I'm shading up because it's greater than. My actual answer, if you graphed it in Desmos, is you would see pretty much something like this in Desmos. Is you would see a solid line here, a dashed line right here, and that. This is the area of the shaded region that works for both. Any point in here could be a solution to the system. Here, a point here, like 6, 0, is a solution to the pink, but not the blue. A point here is a solution to the blue, but not the pink. And here doesn't work for anything. Where does it work? For both. Okay? So, you like pizza? Well, never mind. That's a dumb example. Okay, let's just go to the next one. So now I'm going to do this again. Make sure you know how to graph. This has got to be no big deal. If you need a 5-minute quick on this, I don't mind helping you. Down 6. There's an imaginary 1 here. Up 1, right 1, up 1, right 1. Solid. This should be review. If it's going too quickly, ask me. I don't mind, or go to YouTube. Okay? Less than. And notice how I like the different colors, because then I can see where they overlap. This one. Up 3. Down 5, right 4. Dashed. Greater than means shade up. Now, my actual answer is this region here. If you graphed it on Desmos and you had this dashed line and this solid line, your answer would just be that. And I encourage you to graph it on Desmos. This, any point here, is the solution for both. A point here is a solution for blue, but not pink. A solution for pink, but not blue. A solution for nothing. Now, I will point out, this point that seems like it's on the blue is actually a solution for nothing because it is dashed. What do I mean by that? If I plugged in 0, 3, let me zoom that in a little bit because I want it to make sense. Anything times 0 is 0 plus 3 is 3. Is 3 bigger than 3? No. So if it's on a dashed line, it's not actually included. If I say I have more than $5, if I say I have more than $5 in my pocket, do I have $5 in my pocket? No, but I could have $5.01. Okay. Now, if it said greater than or equal to, it means I have at least $5. So what do I mean by that? Here's the pink. If I picked this point, 0, -6, and I went 0, -6. 0 minus 6 is -6. Is -6 less than or equal to -6? Yes. So this point is a solution. This point is not a solution. Okay? Let's go here. If I was to graph these two, I have to solve for y. Okay? So in this one, I would subtract 11x and then divide by 2. If you're stuck on that, I don't mind helping you with that, okay? But just for time, because a lot of people remember, I don't want to go over that. There's my pink. Down 7. Down 11, right 2. I can't go down 11, right 2. What I can do is go up 11, back 2. So I can go backwards. Dashed. Less than. Shade down. Now some of you go, this one's kind of harder to see. This kind of looks like less than. When I'm struggling, I look at the Y. Where on the Y-axis are the numbers smaller? Are they less than? All the numbers that are less than are down here. Over here, look at that. All these are more. Okay? I actually want to solve this one for Y. So I would subtract 3x. Nothing new. But when I divide by a negative, my inequality switches directions. Let me highlight that. Okay. Now I would graph my blue. Up 7. I'm kind of over, let's see, 2, 4, 6, 7. Up 3, right 2. I'm instead going to go down 1, 2, 3, left 2. Dashed. Greater than. Well, all the y's are bigger up here. So, what does that mean for my answer? All of this is my answer. If you graphed it in Desmos, hopefully I know how to solve for y. I do make mistakes. Let's see, this is dashed, and then this was dashed, and it looks like that's the answer right there. All right. This one, you can solve it for y all by yourself. But just know that if you don't know how to do it and you're just copying mine, you know there's going to be a question like this on the quiz. Okay, so be careful. So now I'm going to go up 4. Hopefully I did that right. Let's see, negative 2x. Yeah. Up 4, up 2, right 1, dashed, less. All the y's are smaller down here. Negative 8. I go up 8, but I don't have a slope. If I don't have a slope, that's 0x. Okay? And it's dashed. So I'm not going up and I'm not going down. And then less than means this. So then what is my actual answer? All of this. So if you were to graph it in Desmos, assuming I know how to graph, it would be shading all of that stuff. Okay? Is a solution only for pink? A solution. Only for blue? A solution. Not a solution. Not a solution? Dashed. If it was solid, it would be a solution. Okay. Now, this time, and not only do we have 2, but we have 3. So we got a pink one, up 1, right 2, solid, down. We got a blue. Down 2, up 2, right 1. And we got a yellow. Good thing I have enough highlighters. Down 3, down 1, over 2. And I'm not wearing my glasses, so I might be off a little bit, okay? And then it's solid, and I'm shading up. Okay. The answer for this one, if you graphed it in Desmos, would be just this region here. Now, why would it just be that region? Because I want to find out where it's pink, blue, and yellow. If I picked this point right here, it's yes for pink and yes for yellow, but no for blue. If I picked a point over here, it's yes for yellow, yes for pink, but not for blue. If I picked it here, it doesn't look like anything, does it? But if I kept going on my yellow, that's an area where it's just yellow. So what if I asked you the question, name a point that is the solution only for the third inequality. Name a point that is a solution for the first and second inequality, but not the third.